Did you know that according to scientists, the Earth was created from the rubble that was left over after a massive cloud of dust and gas collapsed to make the Sun? And yeah, the rubble that eventually gave rise to the Earth spun around the Sun like wheels in motion. The Earth continued to circle the Sun and spin after it was formed, and it is expected to continue to do this for a very long time, or so we thought. Since the Earth's creation some 4.5 billion years ago, it hasn't for one day stopped rotating. Well, all that may just be about to change, as recent developments indicate that the Earth's rotation is, in fact, slowing down and could one day stop. What would this mean for all living things on Earth, and how long do we have before Earth's rotation comes to a stop? Join us as we take a look at how the Earth's rotation is slowing down. You would see a very different globe if you travelled back in time to the Neoproterozoic era, which lasted for around 620 million years. If alien-looking fronds and worms weren't enough to make you want to hurry back to your time machine, you would also notice that the days were different. A day was only around 22 hours long hundreds of millions of years ago, instead of the current 24 hours, because the planet was spinning faster than it is now. The Earth's rotation has been progressively slowing down for billions of years. The process is still in motion, and estimates indicate that it is currently adding 1.8 milliseconds to the duration of a day per century. In addition, the length of the day fluctuates significantly from year to year due to a variety of forces acting on and off the Earth and on its rotation. Scientists still do not completely understand all of the factors that affect changes in the Earth's rotation. However, the development of incredibly sensitive instruments for timing and measuring data has made it possible for them to monitor changes in the rotation of our planet down to the microsecond. The effort has shown that there is a continuous tiny flux in the rotation of the Earth. Every day is distinct from the previous one. Since the Earth's formation, it has been rotating like a top. The natural rotation of celestial bodies is caused by the slow gravitational accretion of drifting pebbles and dust. Even if you set it in motion, the rotation will never be the same. Earth's rotation is affected by both internal and exterior processes, such as the movement of the planet's core and the winds on its surface. Thanks to a method known as Very Long Baseline Interferometry, scientists can now detect even the slightest shifts in the Earth's rotation. It makes use of a network of space telescopes orbiting the Earth and listening for signals from the cosmos. These signals move in and out of view with the rotation of the Earth. Using the time it takes for a signal to go away and then reappear, scientists can precisely determine how long the Earth has been rotating. There is very little that can be done to stop the Earth's rotation. When you let go of the reins on a playground roundabout, it will eventually come to a halt. As it spins, the air and the playground surface presses against it and generates friction, which causes it to slow down. The vast expanse of space is home to our planet's orbit. There isn't even air in outer space to impede Earth's rotation. The Moon, our natural satellite, is by far the most significant and long-lasting force influencing the planet's rotation. The Moon has been gently pulling upon the Earth for billions of years, decreasing the rotation. The Neoproterozoic days were shorter than modern days because of the Moon's pull, and days will be longer in a few million years. The mechanism essentially consists of an energy transfer between Earth and the Moon. The gravitational pull of the Moon causes a little bump to appear close to, but not exactly underneath, the Moon's position on Earth. When the bump's position is different from the Moon, a torque causes the Earth to slow down over time. As the Moon moves away from the Earth at a pace of about 1.5 inches each year, that rotational energy is transmitted to the Moon. The process has been taking place for as long as the Moon has been circling the Earth. One group of academics estimates that 1.4 billion years ago, a day lasted barely 18.7 hours. They estimate that the Moon was 27,000 miles closer to Earth than it is now. The bulges in the Earth's surface move like a wave as it rotates, pushing against the Earth's rotation. This slows down the Earth's spin. As a result, the length of the Earth's day increases by 1 second every 50,000 years. The Earth's rotation could only be stopped if another planet collided with it. Even if this were to occur, it is more likely that this would alter the Earth's rotation rather than completely stop it. There are numerous factors that affect how swiftly the Earth rotates on shorter timespans. The movement of the Earth's molten core is one of the most important of these. It is unclear how much the turbulence within the liquid interior of our planet affects the rotation of the entire planet. Observing the Earth's core is challenging, and researchers are still unable to determine how much it affects the planet's orbit. The wind and wave motions on Earth's surface also affect how quickly the planet rotates. Both the wind and the tides that swirl the waters have an impact on rotational speeds. Because of friction, air currents drag on the Earth's surface and push against mountains, somewhat altering how quickly Earth rotates. The Earth rotates a little bit slower, for instance, during El Niño years because of how the winds change. According to the researchers from NASA's Jet Propulsion Laboratory, the Earth's rotational speed can also be influenced by seismic activity. The Earth's rotation accelerated by around 3 microseconds after the 2004 earthquake that wreaked havoc in Indonesia and other nations bordering the Indian Ocean. As continental plates moved, there was a tiny shift in the distribution of Earth's mass, which led to the effect. The planet will spin more swiftly when mass moves closer to its center, similar to how a figure skater rotates quicker when they pull their arms in, and vice versa. As a direct result of Newton's rule of conservation of energy, the Earth's rotation rate is constantly changing. Relatively more mass is moving, in the form of meltwater, from close to the poles to closer to the equator as glaciers melt and sea levels rise. That slows down the rotation of the Earth and progressively lengthens our days. The speed of Earth's rotation also fluctuates seasonally, picking up speed during the Northern Hemisphere's summer and slowing down during the winter. This is because the Earth's orbit moves it closer to the Sun during winter and slightly farther away during summer. Because of momentum conservation, as the Earth gets closer to the Sun, its rotation slows down to compensate for the increased speed of the planet's motion. Thus, what would occur if it eventually ceased to spin? Well, for one, you wouldn't be propelled into space at a moment's notice if the Earth's rotation stopped. You would still remain securely on the ground, thanks to gravity. But there would be a lot of adjustments. A day would last half a year, as would the night if Earth were to cease spinning yet keep orbiting the Sun. It would become much warmer during the day and much colder during the night. This would impact the Earth's climate. Strong winds would result from a significant temperature differential between day and night, which would pull warm air toward the Earth's cooler night side. Additionally, the wind would go from the warm areas near the equator to the Arctic regions. This does not occur on a rotating Earth because the wind is redirected to the side. The winds from the east and west, as well as the winds from the poles, would collide. They might produce enormous wind swirls the size of entire continents. Part of the Earth's core is made up of molten iron. This molten iron becomes a magnet due to the Earth's rotation, which also creates a magnetic field around the planet. This shields us from dangerous radiation that originates from solar particles and cosmic rays outside the solar system. The magnetic field prevents the radiation from reaching us, but when it does, it interacts with the atmosphere and causes the aurora, often known as the northern or southern lights. However, this radiation might harm humanity if it reaches Earth's surface without the magnetic field. Some birds rely on the magnetic field to navigate, thus they would become disoriented if the Earth stopped spinning. The same constellation of stars would always be visible in the night sky if the Earth didn't spin, since you would always be facing the same way out into space. When compared to viewing the constellations change over the year and stars rise and set during the night, this is entirely different. But don't worry too much about the passing of your days. The difference is minimal and consistent with prior variations in the Earth's revolving speed. Changes in the rotation of our planet should therefore be very low on the list of things to be concerned about, even though the days might never quite be the same length and you might never see Earth as it is anymore. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.